Hi everyone, this is Mrs. Snowbeck. Today we will do Unit 8, Notes 3, and we're going to learn how to find area of trapezoids. So remember what a trapezoid is? A trapezoid has one pair of parallel sides. So like this side and this side are parallel, one pair of parallel sides. The two sides that are parallel are called the bases. So these are both bases, and sometimes we call them base 1 and base 2. And then the height would come down and be perpendicular to those two bases. It has to be 90 degrees. It has to meet them both at 90 degrees. And if we wanted to find the perimeter, we would add up all the sides around the outside of the shape. We would add this plus this plus this plus this. If we want to find the area, there's a formula, and it goes like this. Area equals height, parenthesis, base 1 plus base 2, close the parenthesis, divide by 2. So you add the bases, multiply by the height, divide by 2. Number 1, find the area of the steel used to make the razor blade shown. Find the area. So area, this looks like a trapezoid. It's going to be height times base 1 plus base 2, divide by 2. So let's plug stuff in. Let's see if we know everything. The height. The height is this 1 right here. And so we do know the height. So it's 1, and then the bases are 3, and then plus 2.5, and then divide by 2. Yay, we had everything we needed. So now we type it in our calculator. When you type it in your calculator, do you really need to type in the 1? I don't think so, because timesing by 1 or multiplying by 1 isn't going to change your answer. And so I would just go 3 plus 2.5, and then I would probably hit equals, and then divide by 2. If you're typing it in the correct way, it should be 2.75. And since it's an area, we're going to say centimeters squared. Number 2, one of Ella's trapezoid-shaped handbags is shown. Find the amount of material used to make the side shown. So in other words, we need to find the area of one side of this handbag or purse. It looks like it's a trapezoid, and it says it's a trapezoid. And so we're going to use our formula, height times base 1 plus base 2, divide by 2. Do we know the height? The answer is no. The 30 is this slanted line, which is not the height. The height is the pink dotted line. So we're going to need to find the height. Imagine if we drop another dotted line down over here. This distance between the two dotted lines on top is 28. So down here on bottom, it will also be 28. Now the whole bottom is 58. So 58 minus 28 is 30. So we have 30 left, but part of it has to go here and part of it has to go here. And so let's figure out, if we divide 30 by 2, we get 15. So each of these little distances down here must be 15. Now that's important because now I'm going to outline this in red, you guys. This triangle right here is a right triangle. And this is 15 at the bottom, and this is 30 on the side. So we can do a little a squared plus b squared equals c squared to find the height. And I would go 15 squared plus h squared equals 30 squared. Remember, 30 has to be the longest side, the c, because it's across from the 90. So 15 squared is 225. H squared we don't know. 30 squared is 900. Minus the 225. And you get h squared equals 675. But then remember, you have to take the square root. And h is, it's not a great number, it's 25.98, we'll say. So the good news is, if I erase this little h here, I can fill in the height is 25.98. And we now know the height. So let's fill in what we can into our formula. We know the height, which is 25.98. Then I make a parenthesis. The top base is 28. The bottom base, the whole way across, is 58. And then divide by 2. Now type this in with the parentheses. Like when you grab your calculator, type in 25.8 parenthesis, 28 plus 58, close the parenthesis, and then divide by 2, and then equals. If you do it correctly, it should be 1,117.17, and it's centimeters squared because it's an area. Number 3, Emily designed the silver earrings shown that are shaped like isosceles trapezoids. What is the area of each earring? When it says each earring, it means one earring. What is the area of one earring? So, since it's a trapezoid, we're going to use our formula, height times base 1 plus base 2, divide by 2. Do we know the height? No, we do not. The height would be this red dotted line. The 3 is over here. It is not the height. If we drop down another one, the distance between them is 2. But the whole bottom is 4. 4 minus 2 is 2. And we want half of it over here and half of it over here. So take 2 divided by 2 and we get 1. So that means this must be 1 centimeter, this must be 1 centimeter. Now, look at this triangle over on the left. We have a 3, we have this dotted line, and we have this 1. It's kind of outlined there in yellow. Let's do the Pythagorean theorem. Let's do a squared plus b squared equals c squared. The c has to be the 3. So the 1 squared plus h squared equals 3 squared. 1 squared is 1. H squared we can't do anything with. 3 squared is 9. Minus the 1. H squared equals 8. Take the square root. But the square root of 8 is not a nice number. The square root of h is about 2.83. So there's the height. Let's see if we have enough information to find the area. Area equals height. Ooh, we just found that. That was 2.83. So that's going to go in for the h. Base 1, the top is 2. The bottom all the way across is 4. So 2 plus 4 goes in parentheses and then divide by 2. When you type it in, start by going 2.83 parenthesis, 2 plus 4, close the parenthesis, divide by 2. It should be approximately, it's like 8.4 something, but it rounds to about 8.5 centimeters squared. Number 4, Kevin designed a deck shaped like the trapezoid shown below. Find the area of the deck. So trapezoid area, key words here. Formula is going to be height times base 1 plus base 2, divide by 2. Do we know the height? We actually do. The 4 is the height. So we know height is 4. Base 1, do we know that top base? No. Bottom base is 9. Okay, so we know one of the bases, but it looks like we have to find the other one. So what I'm going to do is I'm going to drop down a dotted line right over here. It's going to be 4 units tall, just like on the left side is 4 units tall. But I think I can find this distance down on the bottom. And the reason that will be helpful is because then if I subtract that distance from 9, I'll know this distance over here, which will be the same as the top base. So to start, I'm going to do a little Pythagorean theorem. I'm going to do a little a squared plus b squared equals c squared, and I'm going to use this triangle, I'm going to outline it in blue here, over on the right. Okay, so it's going to go like this. 4 squared plus, I'll just call this x. How about that? Plus x squared equals 5 squared. The 5 has to be your c because it's across from the 90-degree angle. So 4 squared is 16 plus x squared equals 25 minus 16. X squared equals 9. Ooh, this is nice because the square root of 9 is 3. So I'm just going to erase my x. And I know now that this distance down here is 3. So 9 take away 3, I'll just go over here, 9 take away 3 is 6, which means this distance over here is 6, because they have to add up to 9, and that means the top distance is also 6. And so base 6. Now we have all of the measurements we need for our formula. So go back to your formula. Area equals the height, which is the 4. Parenthesis, base 1 plus base 2. So the top is 6, the bottom is 9. So parenthesis 6 plus 9, and then divide by 2. Type this in your calculator. 4 parenthesis 6 plus 9, close the parenthesis, divide by 2, and you should get a nice number this time. It should be 30. And it's feet squared because it's area. Next, please try Unit 8, Practice 3. If you need help, let me know. Have a great day.